Hey kids, Charlie Abuso here. We're going to work on homework number 1. All right, aluminum bromide. In order to draw the Lewis dot diagrams for these, we have to get the correct formulas. And something that you need to look at the periodic table to figure out is that aluminum is a positive 3 ion. I know that because aluminum has a 283 electron configuration, and it's going to lose 3 electrons to become isoelectric to a noble gas, and that makes it 13 positive protons and only 10 electrons. That gives it a positive 3 charge. Bromine only makes a -1 ion. How do I know that? Bromine has 7 outermost or valence electrons right here. It's a nonmetal. It's going to gain electrons to become isoelectric to krypton. Now, in order to write the formula, we have to crisscross, and we're going to need 1 aluminum and 3 bromines. Now, in order to draw this Lewis dot diagram, we're going to have to show aluminum in its ionic form, which shows aluminum. Its outer orbital is now empty. It was 283 and now becomes 280. And we have to indicate that it's a positive 3 ion. Now, there's going to be 3 bromines. Each one is going to be a -1 charge. Bromines all start out with 7 valence electrons. It's in group 17. Each of them gains 1 electron. So what you're going to have to show here is bromine with its 7 original electrons plus the one it picked up from aluminum, making it a -1 ion. Now, that's aluminum and that's bromine, but we need 3 bromines, so we're going to have to draw 2 more on the bottom. Now, every one of these has to show very clearly that you know it's a -1 ion. There's a positive 3, a -1, a -1, and a -1, and this sums up to 0. That's what has to happen. Every ionic compound sums to 0. Potassium sulfide. Potassium is in group 1. It's a metal. It's going to lose 1 electron. Sulfur is element 16. It's going to have to gain 2. And when we crisscross this, it's going to be K2S. It's in a 2 potassiums to 1 sulfur ratio. The potassium used to have 1 valence electron. It was 2881. Now it's going to become 2880. So we show potassium with an empty valence orbital. And then we have to have 2 of them. So I'm going to show 2 of them. And now I'm going to have a sulfur. Now, sulfur has 6 valence electrons. Put your finger in box 16 and you can see it. But it's going to gain 2 electrons, 1 from each of the potassiums. So the Lewis dot diagram is K2S like that. Zinc only makes a positive 2 ion. We know that because in box number 30 in the top right corner, it's a transitional metal. It doesn't necessarily follow the simple isoelectric rule, but we know it only makes a positive 2 ion. Iodine, just like bromine above it, is in group 17. It only makes a -1 ion. So when we crisscross, it becomes ZnI2. So we have to show zinc as a cation in a bracket with a +2. And now I'm going to show here iodine, which has 7 valence electrons. It's going to gain 1 from zinc. And then the other iodine, because we have to have 2 of them, zinc gives away 2 electrons, but iodines only pick them up 1 at a time. Now, methane. Methane has this formula, CH4. This is different. This is not ionic. The first element is a nonmetal. That means there's going to be no brackets. Now, on the periodic table, which I'm going to show right here, carbon has a 2-4 electron configuration. Oh, it's even bigger right here, 2-4. We don't show the inside electrons. We only show the outside electrons. So we would show carbon with dots like this. But then I'm going to say, you know what? I need to bond 4 hydrogens. So how about I do it this way? Carbon is going to have 4 dots, and those carbon electrons are going to open up. Carbon can make 4 separate bonds. Now, each hydrogen has 1 dot, but they're not alone out here, right? I'm going to put an H on top. I'm going to put an H on the right, an H on the bottom, and an H on the left. Each of these bonds in here shares 1 pair of electrons. There's 4 bonds in 1 molecule here. Each hydrogen bonds to the same carbon. Now, that's something you should just memorize. Carbon dioxide, you know the formula for this. This one is also very important. In this case, the carbon has to only make 2 bonds. Carbon has 4 valence electrons and oxygens have 6. Oxygens have 6 dots. Now, the only way to work this, and you're just going to have to memorize this one, all right, and make it quick, right? This is an important one. You breathe it out all day long. There's the carbon. Now, I'm going to put an oxygen on this side, and I'm going to say there's 2 electrons here, 2 electrons here, and I'm going to put 2 in the middle. And then next to it, I'm going to put 2 electrons on top and bottom, and then 2 more in here. Watch what I'm going to do. These circles are just for teaching. The carbon in the middle is going to borrow 2 electrons from 1 oxygen and 2 from the other, and that gives it a total of 8 outer electrons. When it bonds to 2 oxygens, it gets a full outer orbital. This oxygen has 6 electrons of its own, and it's going to borrow 2 from oxygen and get a full outer orbital. And this oxygen, too, is going to have a full outer orbital. And right in here, that's called a double covalent bond. Double because it shares 2 pairs of electrons. And it's covalent because they're sharing electrons. This next one, titanium Roman numeral 4, that's a metal again. We're back to brackets. Titanium, I'm sorry, I'll do it right here. Titanium makes a +4 and oxygen is a -2. And when we crisscross this, we would get Ti2O4, which is not good. We have to reduce it to TiO2. So TiO2 is going to be our formula. Now, the titanium is a +4 ion, so we would show it in the brackets with a +4 ion. The oxygens have 6 valence electrons, so I'm going to draw an oxygen right here with 6 valence electrons, but it's going to gain 2 from the titanium and become a -2, and then I'm going to have another one down here with 6 valence electrons, and it's going to gain 2 more from the titanium also. We have a +4, a -2, and a -2, and that sums to 0. So the Lewis dot diagram for that ionic compound is right there. Copper, Roman numeral 1, is a +1 ion. Chlorine is a -1 ion. And when we crisscross that, it just looks like this, CuCl in a 1-to-1 ratio. The copper, being a metal, is going to lose its electron, and we're going to show that with a bracket and a +1 ion charge. And right next to it, we're going to put the chlorine. Now, the chlorine has 7 valence electrons, and it's going to get 1 more from the copper and become a -1 ion. And there you have it in a 1-to-1 ratio. The last one is probably the most important molecule for you to learn how to draw. You're just going to have to memorize this. The formula, of course, is H2O. Now, oxygen has 6 valence electrons. And look, there's space for 2 more electrons to come in, which makes good sense. But this is not the right way to look at it at all. Because in order to bond, water, the oxygen electron, and the hydrogen have to share electrons. And if we just put the 2 hydrogens on the bottom, they wouldn't be sharing. Here, we're going to have the oxygen with 6 dots, but we have 2 pairs and 2 open. And then I'm going to put an H on this side and H on the bottom. And it's a bent molecule, not aligned. It's not a line. It's not a straight line. It's bent, and that's water. Homework number 1. Hand it in. Put your name on the top. Bye-bye.